This video is the continuation to the earlier video where I have explained why Nash equilibrium is not the optimal outcome. Okay, the question was like this: we were given the industry demand function, we were given the two firms, firm 1 and firm 2, their cost functions was like this. Total cost for firm 1 was 20q1, total cost for firm 2 was 20q2. Okay, first we solved for Carnot Nash equilibrium. Okay, so first, for solving the according to the Carnot Nash equilibrium, first we find the reaction function for firm 1. Okay, so reaction function, how do we find? First we write the total revenue for firm 1, that came out to be this very thing. Okay, after that we calculated the marginal revenue for the firm 1. Okay, and we know that the profit maximization condition requires marginal revenue for first firm should be equal to its marginal cost. Total cost was this, its marginal cost will be equal to the derivative of this total cost. Okay, and when we solve this marginal revenue is equal to marginal cost, we get the value of q1 is equal to 120 minus q2 upon 2. This was the reaction function for firm 1. Okay, where the reaction function simply means the optimal quantity that firm 1 should produce given what we call the output produced by firm 2. Okay, similarly, when we solved for reaction function for firm 2, the q2 comes out to be 120 minus q1 upon 2. Okay, when we solve for q1 and q2, we got q1 is equal to 40, q2 is equal to 40. That means Carnot Nash equilibrium requires that firm 1 should produce 40, firm 2 should also produce 40, and profit in case of Carnot Nash equilibrium was 1600 for both the firms, and price was 60. I have explained this in detail in the earlier video. I will put a link into the info button and also into the description box, so that you get how did I solve it. Okay, this was according to when the fourth firms were producing according to their reaction functions. Okay, after that we were told to find what happens if they jointly produce. That means what happens if the both firms produce jointly. That means they form the cartel. Okay, in case of cartel, total industry demand will be equal to 140, q1 plus q2 will be equal to q. Okay, now total revenue is simply price into q, that comes out to be this very thing. Marginal revenue, since the marginal cost, sorry, is same for the both the firms, so the marginal cost will be 2, the derivative of the total cost function of the either of the firms. Okay, for profit maximization requires marginal revenue should be equal to marginal cost. Okay, when we solve this is marginal revenue, this is marginal cost, so according to the cattle production, there will be 60 units produced. Okay, since total production is 60, so this 60 units will be divided between the two firms. That means firm 1 will have 30 units, firm 2 will have 30 units. Okay, since only two firms are in this case. Okay, and when we solve for the profits, that is profit is price into quantity minus total cost. I have explained this whole step in the earlier video, you can check there. Okay, so profit for firm 1 was 1800, profit for firm 2 was 1800 also. Okay, and price according to cattle formation was 80. Okay, now the third was what happens if one firm breaks the cattle. In case of, we have shown in earlier video, if firm 1 breaks the cattle and firm 2 sticks to the output level produced according to the cattle. Okay, so let us say firm 2 was producing according to the cattle. Okay, firm 2 was producing this very thing, and firm 1 will use this very information that firm 2 will produce according to the cattle. He will use his reaction function in producing the output. Okay, the firm 1's reaction function was this very function. Okay, when we substitute this 30 in this question, we get firm 1 will produce 45 units. Okay, profit in this case will be, profit for firm 1 will be 2025. Okay, when he is producing according to the reaction function, and profit for firm 2 will be equal to 1350 when he sticks to the cattle agreement. Okay, and in case of Nash equilibrium, what we call Nash equilibrium, no firm has any incentive to take a unilateral decision, and I will explain it here. Okay, so this was the thing. Okay, now you can now ask the question, why does not the firms choose to produce according to the cattle? Because cattle gives both the firms profit greater than what it happens according when they produce it according to their reaction functions. Okay, so I have just used all these data and formed the payoff matrix for the firms in terms of their profits. Okay, now here you can easily see, let us see uh, how this 1600 is the Nash equilibrium and why this 1800 is not the optimal outcome. Okay, now as we have seen, if firm 1 chooses to produce according to the reaction function, he gets 1600, and if firm 2 also chooses to produce according to the reaction function, he or she gets 1600 profits. Okay, both get 1600. Okay, if firm 1 chooses to produce according to the Cottle, he will get only 1350, and if firm 2 chooses to produce according to the reaction function, he will get 2025. Okay, similarly, if firm 1 chooses according to the reaction function, he gets 2025, and firm 2, if producing according to the Cottle, gets 1350. Okay, now let us see what is obviously when both the firms choose to produce according to the Cottle, both get 1800 as profit. Okay, now let us see what is the Nash equilibrium here. Okay, now what is the Nash equilibrium? I have explained it earlier also in the game theory. Nash equilibrium is when no player in a game can increase his payoff by unilaterally changing their action or strategy. Okay, so let us see how this is possible. Since if let us see what does this mean. If firm 1 chooses to produce according to his reaction function, okay, let us say firm 1 chooses to produce according to the Cottle. Okay, so he gets less profit choose if he produces according to the Cottle. Okay, so it is here L. Okay, so similarly similar is the case for firm 2. Firm 2 gets 1600 if he chooses to produce according to his reaction function. If he deviates from this strategy, what she gets only 1350. We can say that 1600 is obviously their dominant strategy. By dominant strategy, what we mean, dominant let me write it here. Dominant strategy, okay, refers to the optimal option for a player among all the competitive strategies strategy set. Let me write it here. Set no matter how that player's opponent may play. Okay, we say this 1600 is also the dominant strategy. Okay, so it refers to the optimal option for a player among all the competitive strategies, no matter how that player's opponent may play. Okay, it does not here, if we can see here, firm 1 will always choose to play according to the reaction function, no matter what firm 2 chooses. And we can see here whether firm 2 plays according to reaction function or according to the Cottle, firm 1 will always choose to play according to the reaction function, because here we can say this first row dominates the second row. These blue numbers in the rows, 1600 is greater than 1350, 2025 is greater than 1800. We say that reaction function for firm 1 is the dominant strategy. Okay, because playing according to the reaction function gives him more payoff than playing according to the Cottle. Similar case is for firm 2. No matter what firm 1 chooses, whether firm 1 chooses to play according to the reaction function or according to the Cottle. Firm 2 will always choose to produce according to the reaction function. And here we can see these columns. This reaction function column of firm 2 dominates this reaction function this column when producing according to the Cottle. Okay, so dominant strategy for both the players will be to play according to their reaction functions. Okay, and why this 1800 is not the optimal outcome in this case? Because this 1800 in this case, what we call this can be the optimal output. Okay, but in this case both the players have an incentive to unilaterally change their strategy. How? Let us say firm here firm 1 chooses to play according to the reaction function. Okay, and firm 2 chooses to produce according to the Cottle. Okay, so if firm 1 deviates from producing according to the Cottle, he gets 2025, which we have shown it here. Why Cottle and Cottle is not the optimal outcome? Because any firm, any one firm which deviates from this strategy, okay, gains. Okay, and another firm loses. That means one firm is better off when he breaks the Cottle, and another firm is worse off, because we have seen when firm 1 breaks the Cottle, firm 1 gets 2025 as the profit. And if firm 2 sticks to the what we call to the Cottle agreement, he gets only 1350. Okay, so why this 1800 is not the perfect what we call the optimal outcome? Because any one firm, if any of the firm deviates unilaterally, the profits will change. But here there is no incentive for any firm to deviate from their dominant strategies. Okay, so I have told you by dominant strategy what we mean. No matter what other firm does, further firm 1 will always choose to play according to the reaction function. Similarly, no matter what firm 1 chooses, firm 2 will always choose to produce according to the reaction function. Okay, and can we find out the Nash equilibrium? We can always find the Nash equilibrium. And let us see what is the Nash equilibrium in this case. Okay, let us say firm 1 chooses 1600. Okay, let us say firm 1 chooses to produce according to the reaction function. Firm 2 has two options, either to produce according to reaction function or Cottle. So producing according to the reaction function gives him 1600, producing according to the Cottle gives him 1350. Obviously this number is greater than this, so firm 2 will choose to produce according to the reaction function. Let us say firm 1 decides to produce according to the Cottle. Again, firm 2 has two options, either to produce according to the reaction function or according to the Cottle. Obviously here we can see firm 1 is better off when he chooses to produce according to the reaction function. So let us uh, underline this. Okay, now let us see what happens in terms of firm 2 when firm 2 chooses its strategy. Let us say firm 2 chooses to play according to the reaction function. Okay, then firm 1 has two options, either to play according to the reaction function or according to the Cottle gives 1350, reaction function gives 1600. Obviously 1600 is greater than 1350, so firm 1 will choose to produce according to the reaction function. Similarly, let us say firm 2 chooses to produce according to the Cottle. Okay, firm 1 again has two options, either to go for reaction function or according to the Cottle. Okay, Cottle gives 1800 as profit, reaction function gives him 2025, so firm 1 will choose this very number. Okay, now where does the Nash equilibrium occurs? Nash equilibrium occurs when we have both the numbers underlined or encircled, and we can say this 1600 is obviously the Nash equilibrium in this case. Okay, what we call the, in this case we have Carnot Nash equilibrium. Okay, so this 1800 is not an optimal outcome here. Okay, in this case both the players can unilaterally deviate from their strategies. Okay, but here no firm has any incentive to change his strategies. Let us, for the sake of example, firm one chooses to deviate from this strategy of playing according to the reaction function. If he deviates, he gets only 1350. Okay, so firm 1 is worse off. Similarly, if firm 2 deviates from this dominant strategy, okay, this Nash equilibrium outcome, so when she deviates, he produces according to the Cottle, he gets worse off here, and we have seen here. That is why this Nash equilibrium is also the dominant strategy, or to say so, dominant strategy always gives us the Nash equilibrium. 1800 can be the Pareto, what we call the improvement. This is Pareto inefficient, this cannot be, but this is Pareto improvement here. Okay, so both players, if they uh, what we call, if they make an agreement, okay, prior to playing this game, that both will play according to the Cottle, then they will get 1800 and 1800. But if any of the player defects or breaks the Cottle, the profits change drastically, as I have shown. Okay, I hope I make myself clear in this video. Actually, I have made it earlier, and you can check the full explanation. I was just giving the explanations how this 1800 and 1800 is not the Nash equilibrium in this case. Okay, so let me repeat again. This cannot be the optimal outcome because both the firms have an incentive to unilaterally change their decision. Okay, that means if both are producing according to the Cottle, if any of the firm breaks the Cottle, okay, let us say firm 1 breaks the Cottle. If firm 1 breaks the Cottle, he will get profit of 2025, and firm 2 will be worse off. Okay, so this is better off, firm 1 is better off, firm 2 is worse off. So this cannot be a stable outcome, but this is the stable outcome. No firm has any incentive to change from this decision, from this strategy. Okay, I hope I make myself clear. Thank you.